Okay, let's start to see more into practice what we have seen theoretically up to now. So, in order to focus on shaders coding and to be in a way consistent with the usual OpenGL practice in programming, we don't want to hard code any longer inside the JavaScript code the part related to GLSL. So this means basically to have the shaders code in two separated files, not JavaScript files, GLSL files. We will have vs.glsl, fs.glsl containing each one its shader program. In order to load files, external files in JavaScript, the easiest solution is to issue an XML HTTP request, which unfortunately is blocked by many browsers unless, for security reasons, unless you do some tricks, but we don't want to do tricks. So we are going to set up a web server. The easiest one I found, and also very unsecure web server, is just an extension of Google. Probably there are other much better. If you want to use any other web server you have on your machine, you are very welcome to do that. But otherwise, if you go on the web store of Chrome, there is this web server for Chrome, you think, very original name, that you can add as a plugin to your browser and use it, search for it, add it, etc. Yeah, that should be updated. Okay, so this is the first thing we are going to do. If you want to, okay, we choose folder, you choose the root of this web server, just choose the directory in which you are saving your JavaScript and HTML files, not subfolder, otherwise it won't work. And you add the address at which you can access all your files. Okay, so let's start by doing something like this. If we open Chrome, if I open Chrome, okay, application, okay, we choose as a folder the one in which we code. Okay, so the server is running and something happens if I select this. Okay, the server is there. In the utils for this lesson, there are a couple of files. Drawing, JS, index, and utils are those coming from the latest example. I just added this cube definition 4, which we are going to use now. I copy all of this inside the code folder. Code folder is the root of the web server, and the first thing we are going to do is to create a folder that we call shaders, so we can put everything about shaders just in one folder. Here we create two files, vs.glsl and fs.glsl. We can open them, and then we can open 1, 2, and 3 files. Okay. The first thing that we of course need to do is to change cube definition in index.html to 4. The other doesn't exist. Okay. Cube definition 4 is pretty much similar to the one that we used last time, cube definition 3. The difference is that now we don't have just positive positive floating point values. We can also have negative values. And you will see that those vertices are not replicated by itself. So for example, this one is different from this one. Even if the coordinate, the x, y, and z coordinate are the same, we have different values for the normals. So even if in the space those vertices are going to overlap, they will contribute to a different face of the cube. Why? Because the normal is pointing another direction. And we are going to assemble all those vertices using the indexes as we have seen last time Monday. Well, okay. The first thing that we can do is go in drawing and copy all the part between without the quotes vs, we copy all its content into vs.jlsl, and then we put some return to better understand the code. Okay, so what we see here, we see a very basic vertex shader. We have two attributes, so two input values concerning and varying for each of the vertices, which are the position, a vector containing the x, y, z values of the position of the vertex, and the color we want to associate to that vertex. We also want that since we perform some, let's say we can, even if we don't, but we can make some modification to the color, because we want the color to be interpolated and go to the next stage. So we create these variables in order to send the interpolated value of the color to the next stage. We also need a uniform, something that doesn't change for all the vertices, which is the matrix. And inside the main, we do this. Simply, the varying color, the color exiting this stage, is going to be exactly equal to the one entering. The only difference is that it's going to be interpolated. But we don't perform any specific function, any operation on that. And as you see, at the end of my vertex shader, there is this GL position function. And with it, we are asking WebGL to do this. First thing to consider is that P matrix, our projection matrix, is a matrix 4, but the position is just a vec 3. So we cannot multiply directly the matrix 4 by 4 to a vector 3. We need to transform the vector from 3 to 4, considering that the fourth value of, in this case, is just the W, the scale factor. We don't have any scaling, so we can just put it to 1, and now no errors happens at this level. So we want that the final position of the vertex in position 1 is the vertex multiplied by the projection matrix. And that's what this syntax is for. Let's do the same for the fragment shader, collecting this part here and putting inside fragment shader. As you see, the first line is the statement about the precision that we want. We just need a medium precision, so we don't waste resources. We just have one input, which is the varying color coming from the previous stage, the color which is interpolated. And as a fragment color, the final color, we just transform the incoming color in a vector 4, because frag color requires a vector 4, RGBA as a coding for a color. So we have our couple of vertex plus fragment shader. Now we have to modify the code in order to include these changes. So more precisely, we can call this program shader program. It is important that we change everywhere there was program, shader program. Okay, basically just there. It's for compiling. We don't need any more matrix. Those two are good, and also the handles are pretty right. We should remember to do something here. It's not required to do it now, but otherwise I forgot about that. And is to pass one parameters inside the possible list, which is alpha false. We can copy this here. This is just I will explain why we are doing this later, but know that it's just a default of WebGL to consider any black, so any point of an object not struck by light as black, but that black has an alpha value of 0, so it becomes transparent and it filters the background color, and we don't want that. That's why we put a false here. I will show you the difference of using it and not using it. Okay. Another thing that we need to add is a variable. Let's call it shader here. And we put the same name. I hope we use the same name. Okay, that we use it here. So shader dir is referring to this folder here. Okay. So now, after creating all the buffer, after sending all the data to the GPU memory, we have to collect the strings composing shaders code from the shaders file, compile them, link them to a program, and then use the program. For doing this, we are going to issue this, to call this function, which is in utils, is log file. Log file is, let's say, a bit tricky as a function, because there are callbacks and stuff like that. So it's not required for you to know how it works, but it works. So shader file, shader here, plus yes.glsl is the first element composing this array we are creating on flight as one of the parameters passed to the function. And the second one is exactly the same thing, but with fs. Okay. So we are asking this function load file to look to all the files listed into this array, and once it found those files, the function will call this callback function that we create and declare here. The function is going to have a shader text value here, which is the return of load file. That's why it's pretty complicated. So load files loads those two files inside the array, decode them and parse them, and sends the parsed results into this array created by the function, which is called shader text, to another function that will process everything now. Why this complicated game of callbacks? Well, you are not going to have those programs if you program in C++, C#, OpenGL directly. But since here there is the synchronicity problem, because the function may load the content or delay the loading of the content because it is a network thing, you don't know when it is ready and the content has been loaded, so to process it. The best way is to have a callback, which you are sure it will be called at the end of all of the process. Okay, so we can now delete those two lines. Oh, there is a shader program here too. Okay, also this is not required. So inside the shader function we have to move more or less all the operations that were previously taken outside. So we can, for example, just copy the first part, put it down here. We're going to modify it a little bit. So instead of v1 we can more completely say vertex shader, for example. We create a shader holder of the type vertex shader. Then we bind it as a vertex shader, and instead of that we put, since it was an array, the first parsed file in shader text. Then we ask to compile everything. We have to substitute also here. The if block is just error checking. If we get any problems in compiling, we get an alert about that. But the important lines are those three. We create the shader holder. We load inside it the code taken from the file, and we compile the code. Then we can also move inside this function everything concerning the fragment, and of course now we can create a fragment shader. We create the shader, we pass the source, so now it's a shader text 1. I forgot, sorry. Okay, shader text 1, and then we have to update error in fs shader. Okay, So we have collected and compiled the two shaders code. At this point we can finally create the shader program, attach and link everything to it. Of course, changing properly names. Mind that here and here it is correct. I don't think there are any other. Okay. So if I now try to execute it index.html, I don't see nothing. You see that directly I cannot issue a cross-origin request, so everything is blocked. Let's go from here. Okay, we don't see anything, but the error is different at least. Utils.d. Oh, I forgot a file. No. Okay, let's check the error. Okay, one of the file I asked to load is not there. Let's check the names. Okay, so this is the results that you have. Nothing too different from what we got last time, except that now we have some black face. And the black faces exist because now we have negative values, because the values are meant to be for normals, and normals can have negative floating values, which color cannot. So that's why there are black faces. Now we want to change this, and instead of just showing colors, we want to create a material for the object, we want to create a directional light to hit the object, and using plain Lambert reflection to see how this cube can be illuminated. Okay, the first thing that we need to do is to go inside the vertex shader code and do some changes. We start by changing the names, more explicative ones, so in position, for example, in normal, meaning that the first attribute are about the x, y, z, and the second one is no longer a color, but they are normals. In order to avoid name clashes, we call the normals interpolated sent to the next stage as fs normals. And P matrix becomes the word view projection matrix. So fs normal becomes equal to normal gel position multiplies matrix for in position. The code is exactly the same, just the names changes. Now, instead, the fragment shader is going to change a little bit more. Indeed, a little bit more. Where we had just the color, now we have the normals, but we need at least 3 more uniform. The first uniform that we need is a vector 4. Let's call it MD color. It stands for the material cube material color. Another uniform, this time a vector 3, is going to be light direction. We want to use one directional light. Directional light are expressed and defined only by their direction, so a vector 3 is more than enough. And the last uniform, this time called light color, just to have the color of light. Obviously, frag color is now computed differently. You know, for the theoretical part, that we have to multiply the color of the surface for the light color. For the dot product, really means, because the direction has to be fixed, between light direction and the normal. Okay, there are a couple of things that can be added here. The first one is that we don't want any negative values for the normals, so nothing that goes inside the object but just goes outside. So we have to use this function, which is one of the different ways you can do that. The maximum between the results of the dot product and 0, so it cannot go under 0. And another thing that we are going to do, but for now is pretty useless, but it becomes useful later, is to normalize fs normal. Because when next lesson we are going to perform some multiplication to the normals in order to do things, after those multiplication we can have that the normal now is outside the range 0, 1, and we want to normalize it again. Okay, so now we have a pretty different fragment shader. If we now try to execute the code, we don't see almost anything. Why? We have to pass data to the new uniform we just created. We never specify a direction for the light, we just asked for one, the color, and so on. So we need to go inside the drawing, and first thing, we don't have a vertex color handle anymore, but it's going to be a vertex normal handle. Okay. Position of the vertices, normal of the vertices, and the matrix position is maybe too much. Let's not create more problems. Okay. Then 3 more. Material. The position where we want to send the color for the material. Light direction handle, the position where we want to send the direction of light, and light color handle. Okay. Now we have all the handles that we need. And in the same way, we specified parameters for the camera and then for the cube. Now we need to specify parameters for light, for example. Okay. Just to allow you to easily change the direction of light without having to specify it in radiant, which is how it is expected by the formula, we do something like this. Okay, light, let's call it, I don't know, light alpha, which is going to be minus utils dot okay, so let's say that we want light 60 degrees toward left, and let's create beta utils tag to right. You can try changes to change them as values. At this point we can finally have the directional light. An array of 3 values. You are not required to remember or understand those formulas. It's just to create a vector for the direction of light. So there are so many ways, different ways for doing the same thing that the last one. So now we have a vector tree, which is expected here as a vector tree for light direction. All we have to do is to send to send it to the shader. Also, we need, of course, variable directional light color, and you can choose the color that you prefer. Let's put something like this. Something toward, let's say, blue, gray blue. And last one, the last one is the cube. The cube material color. And in this case, probably we want it all the way. The standard color of many Blender, for example, the standard shader of 3D authoring tools. So the things that we did here is to prepare collecting the position where to send the data. And here we created the data. Now we have to send them. I also want to change the initial position of camera, moving it a little bit far away. Let's put everything in 0. Okay. after the program has been compiled and it is the actual shader used, you see here that we are collecting the handles. We have 3 more handles to collect, and we have to change the names here. Vertex now is in position, so instead of pos1 we put in position. Instead of color 1 we have in normal, and the matrix changed to okay. So now our code is able to understand where to send the data. We can look at here, they are all uniforms, so we can copy this line and paste it thrice. We are getting uniforms, of course with different names. So mDiffColor, material diffuse color handle, becomes mDiffColor. Light direction, which is a vector 3, we can put it here. Light direction, yes. Okay, and then light color. Okay. Again, okay, at least there are no complaining. Yes, there are complaining. Let's see where. Unexpected number. Oh yes, too many zeros. Okay. No errors, that's good. Now we have to send all the information that we have. And we can do it here. Okay. So it's more or less the same, just let me, okay, uniform for gl.uniform for fv. We are sending a uniform composed by 4 floating values. We want to send it to let's say this is the material, so we want to send it to material, and we want to send a new float 32 array made of this is the material diffuse color, so we go here, we take cube material color and we paste it here. So the line is this one, GL uniform for FV. If you don't put the V, you can do the same, but you have to explicitly say cube material color 0, comma, cube material color 1, etc. for all 4 values that you are passing. With FV, and by typing a generic var array, you can just send it in this way. You can copy and paste this line twice, remembering 3 in the second one and 4 in the last one. Why? Because now we have a direction to pass, light direction, which is defined here, directional light. Okay, so we have to send it here and also correct handle. Okay, so the second line is this one. We send 3 floating values at this position where the direction of light is expected by creating a new float 32 array out of our directional light definition. Now we have to send the light color, quindi directional light color, and of course the handle is light color handle. Okay. We have also to change here vertex normal handle, because we don't have the color any longer. Is the color correct? And also here we have to put vertex normal handle. And now we have a cube which is floating around, struck by the light which hit one of its faces more than the other, and because of this it produces this effect. So let's now see a couple of things. You can of course try to change light direction with different degree values, change the color of the material, so to see how light impact on the surface. If you just want to see the color of one, only the color of light or only the color of the material, just put the other one to white. So if, for example, we decide that the color is going to be red for our cube, and we want to see it red, we put the light to white and the material color to red, of course, which should be probably the same effect if we switch them. Almost. Yeah, basically more or less the same effect. About what I was telling you, this. That's what happens if we don't put the alpha out, which is not the intended effect, since we have put that we want the background black. We can also force the background to be black, but the faces of the cube are not going to be black. Again, because, to put it simple, browsers handle transparency because of the windowing system in a very different way from how your code in C++ is going to be to handle transparency under the same conditions. Okay. I think we don't have time for another example because it's pretty long. I introduce it and then next time I'll show you. One of the advantages of putting in a buffer all the data regarding the cube is that now we can replicate the cube in our scene as many times as we want without having to send again the data. We just instance it more than once, which is done basically by making a cycle of the rendering cycle, this part here. Let me show you. If you make a cycle of all this part, each time giving a different word matrix to compute the projection matrix, you are going to put the cube in a different position, basically instancing the cube more than once in your scene, with very little effort in terms of performances and resources. Okay, so with today's lesson you should have a broad overview of all the process, which started from JavaScript and reached GLSL. GLSL part seems pretty hard to understand, but only because you have to practice a little bit. That's my advice for your exam. Every time you have to deal with something that have coding, just code. And if there is something wrong, the compiler tells you that you are making a mistake. So it should be, in theory, one of the easiest part to learn. But you have to do that. It's not something that you can simply study theoretically. We will see more complex example of shaders so that you can have all the information required for writing shaders at the exam. Because this part at the exam is about writing shaders given some statement. Write shaders able to do this, this, and this. Or you have a list, the code, simply a code which contains mistakes, and you should point out how many mistakes and how to correct them. But it's important that you try to code and understand how this works. Okay, so for today we are done.